Chapter 3, the I measure. In this chapter, we are going to study the set theoretic structure of Shannon's information measures. In particular, we will answer the question why Shannon's information measures can be represented by a form of Venn diagram called the information diagram. We are going to learn how to use information diagrams to obtain information identities and inequalities. And we are going to discuss some problem-solving examples. We have seen before this set theoretic representation of Shannon's information measures for two random variables x1 and x2, entropy of x1, entropy of x2, the joint entropy of x1 and x2, the conditional entropy of x1 given x2, the conditional entropy of x2 given x1, and the mutual information between x1 and x2. So what is the precise relation between information measures and set theory? Here, we introduce a formal substitution of symbols. On the left-hand side is a set of symbols in information theory. On the right-hand side is a corresponding symbols in set theory. Specifically, H or I, that represents entropy or mutual information in information theory, corresponds to mu star in set theory, where mu star is some signed measure or set additive function. For a comma in information theory, it corresponds to the union in set theory. For the semicolon in information theory, it corresponds to the intersection in set theory. For the conditioning bar in information theory, it corresponds to set minus in set theory, that is, A minus B is equal to A intersect B complement. Here are some examples. The entropy of x1 given x2 corresponds to mu star of x1 tilde minus x2 tilde, where x1 tilde is a set variable that corresponds to the random variable x1, and x2 tilde is a set variable that corresponds to the random variable x2. The entropy of x2 given x1 corresponds to mu star of x2 tilde minus x1 tilde. And the mutual information between x1 and x2 corresponds to mu star x1 tilde intersect x2 tilde. Here is another example. In set theory, we have the celebrated inclusion-exclusion formula, which says that mu star x1 tilde union x2 tilde is equal to mu star x1 tilde plus mu star x2 tilde minus mu star x1 tilde intersect x2 tilde. This corresponds to the identity in information theory, entropy of x1, comma, x2 equals the entropy of x1 plus the entropy of x2 minus the mutual information x1 semicolon x2. Section 3.1 are some preliminaries. Here we introduce some elementary concepts in measure theory. The field Fn generated by sets x1 tilde, x2 tilde, up to xn tilde is the collection of sets which can be obtained by any sequence of usual set operations, that is, union, intersection, complement, and difference, on set variables x1 tilde, x2 tilde, up to xn tilde. The atoms of the field Fn are sets of the form intersection I equals 1 up to n, yi, where yi is either xi tilde or xi tilde complement. Here is an example for F2, the field generated by the sets x1 tilde and x2 tilde. There are 4 atoms in F2. x1 tilde intersect x2 tilde, x1 tilde complement intersect x2 tilde, x1 tilde intersects x2 tilde complement, and x1 tilde complement intersects x2 tilde complement. There are a total of 2 to the power 4 equals 16 sets in F2 formed by the unions of the above 4 atoms. A real function mu defined on Fn is called a signed measure if it is set additive. That is, for disjoint A and B in Fn, we have mu A union B is equal to mu A plus mu B. The set additivity property is satisfied by the weight of objects. For example, the weight of 2 distinct objects is equal to the weight of the first object plus the weight of the second object. For any set additive function mu, it can be shown that mu of the empty set is equal to 0, because for any set A, we have mu A is equal to mu A union the empty set by set additivity is equal to mu A plus mu of the empty set. So now we have mu A equals mu A plus mu empty set. After cancelling mu A, we see that mu on the empty set is equal to 0. A signed measure can take positive or negative values. If a signed measure takes only positive values, it is simply called a measure. Here is an example. A signed measure mu on F2 is completely specified by the values on the 4 atoms that we have seen before. The value of mu on the other sets in F2 are obtained by set additivity. For example, mu on the set x1 tilde is equal to mu on the atom x1 tilde intersect x2 tilde union the atom x1 tilde intersect x2 tilde complement. By set additivity, this is equal to mu on x1 tilde intersect x2 tilde plus mu on x1 tilde intersect x2 tilde complement.